Let's look at this problem, decode string. Given an encoded string, return its decoded string. The encoding rule is k encoded string, where the encoded string inside the square bracket is being repeated exactly k times. Note that k is guaranteed to be a positive integer. You may assume that the input string is always valid, no actual white spaces, square brackets are well formed, etc. Furthermore, you may assume that the original data does not contain any digits, and that the digits are only for those repeated numbers. Okay, for example, there won't be input like 3a or 24. Okay, let's take a look at the example 3a. So this became 3a, and bc repeated 2 times. For this one, 3, and this string repeated 3 times. And for this string, it is a plus 2c. All right. And okay, let's look at this problem. We have ABC repeated 2 times, and 3 CD, and 1 EF. And here ABC and CD 3 times, and XYZ. Okay, I think I understand the rules. In this case, we need to detect this kind of bracket pairs. Looks like we need to use stack somehow, and say if we use stack, can we extract this? So we push this in, and we push this in. Once we see this, we get this string, and we can get the number corresponding to this string, and we can create this. Once we created this, we can we keep going. We meet another ending brackets, and since we meet another ending brackets, we can pop out the string between the starting brackets and the ending brackets. So we added A, ACC, and finally we apply the number, and we repeat that 3 times. Okay, looks like promising. Let me see this case. If I push in 1 brackets, and I start to register those strings. Once I see the ending brackets, the string I just registered need to be repeated 2 times. Then I get this string, and I go further. I see a number. Once I see a number, I know next one is opening brackets, and I start to register the strings until I find the ending brackets, and then what I already registered need to be repeated 3 times, and I add those strings into the final string, and I go since I didn't meet any number or brackets, I'm just appending those to the final string. Okay, that looks like a working solution. Now let me go back here. Again, first I meet a number, then I know next one is opening brackets, and let's start a register a string, a character, and then I meet another number, and then I know next one is again opening brackets. In that case, I register. In this case, I have to register another character. It's better to be a recursive function call. The function call returns when I see a ending brackets, and the function will return me the string I just registered. Once it's returned, I will repeat it, that string this number of times. And once I repeated that string this number of times, I start to read further, and I meet this string, and I know what I already accumulated is a string I need to return. And I return, as the outer layer I meet a number, and then that constructed my whole string. Okay, I think this might be a solution. For the time complexity, I only have to read each character once, and so the time complexity will be O(n), and space complexity, it's hard to estimate at this point. So let's write this program, and then we will see what's the time complexity, what's the space complexity. Okay, so let's do a string reg equal. Okay, next let's do sysout print line and solve. So reg private static string solve string reg. Oh, let's do this. Let's do a string result equal at beginning is nothing, empty string, and we can use private static. So let's do a solution equal new. Okay. Alright, now we have that. Let's don't use private. And we need to return the result. Finally, we need to return the result. Let's just do void. Shall we? And the result is our solution. Okay. Here let's do void. Regular expression. So that's for For first, let's break down this into a char array. Okay, char array equal reg to char array to char array. Now we have this char array for int I equals 0, I below array length plus and we have this char array. So char c equal array integer I. So now I have this character if there's a trigger. If char minus 0, let's say minus 0, it should be above 0, right? And char and 9 minus char should be below or equal. Below or equal. It could be included 0. So let's have that. It included 0. So from 0 to 9. Then we know we just need a number. Okay, for this number, we need to parse this number. Int multi equal integer char at integer parse int char, right? It's what it says. String canards. Okay, that's easy. All right. We have that number. Then the next have to be brackets. Then the next we should say. Then the next we should say. We just pass you in string decoded equal. Let's just say solve. Let's give you the give you the rest of the string. I would say string solve. You should return me a string, right? Otherwise, it's not good. And we have rag substring. Okay. I. This is exclusive, inclusive. At the current position, I should start at next position. Once you return me that, what I can do is for int j equal 0, j below multi j plus plus then what I do, I need to have a string buffer. I need to return you something. Let me create a string first. Let me create a string buffer. I don't know how many times you're gonna to repeat. So string buffer sb equal new string buffer. So for this case, you say sb dot append decoded. So your multi is 3, then I decoded 3 times. Finally, this is what I do when I meet a number. Okay, I go through the end, then I will return. I just parse to you the I should let me see. I should pass you this, right? But it could possible you have something like ABC, and you have a 2C, something like this. So I don't expect you to do the whole thing. I should just pass you this and expect you to return me the result. How do I know the boundary? The answer is I don't. If I don't know the boundary, then how I'm going to continue after this? One way I can do is I can first go through the array and I get the position of this, and I know this thing is a string I need to decode, and that's what I pass in. And I add that to my final string. Then I go further. So in this case, let me don't blindly pass you that. This way, let me don't blindly pass you that. What I need to pass you is the string between I and the closing bracket. So let me say, let me give you a counter, and then let me give you the regular expression, the rest of regular expression. Now you return me the length. Then I will say substring here and the length I plus 1 plus length. Say what's the length? Length equal 2, I would say. Length equal 2. That means length equals 3. So 1, 2, 3. I would add that, and that is a substring I want you to to solve. Once you solved, then I just string buffer I append it. Now I have that string buffer. Then what I do? I add that to the final result. Append SB to string. Okay. So now result SB to string. I just exhausted this part. So after that, I can advance the I plus equal 11. Right? I just skip a lot of characters. Else if char equal that's not a for this equal opening brackets or C equal closing brackets. In this case, what do we do? That's a starting brackets. It's always followed by our starting brackets. Solver, let's say, support log or solve. That's cool. Decoder, right? Decoder. In that case, once you meet number, then you'll never meet this again. I will show that. Should never enter here. Else if then C equal else. Else then C equal any other characters. We just result append what is the result? Result not string buffer, let's say string buffer equal new string buffer. Okay. without append, we would do C plus empty string. This is append until we meet the next. Okay, in this case, this is not a good algorithm, I can tell, because I will push until I find a balanced. Then I know the position. Counter. Let's implement the counter. Void. Okay, void. Let's do the counter private int counter. So give me an int, give me a string str. Give me a string. I know the string start was a starting brackets, so char array equal str to char array. Now we have those. That's for int I equal 0, I below, array length, I plus plus. Okay. Char C equal array at index I. So let's add a counter. Accumulator. Brackets counter. Int brackets equals 0 char if now that put I here in the I equals 0. Int I equals 0. Start from I equals 0 to array length char if char equal starting brackets, right? What I do brackets plus plus, I mean open brackets, if C equal closing brackets minus minus. At that point, if brackets equals 0, then break. Let me return I. That is the length. The first one. Then the second one. The first one I go through. It's definitely not a 0, but say the next one. At position 0, 1, 2. At position 2. I need a closing brackets, so I return. That is my length. The length is this plus 1. So this is a length. Now I got the length. Then I know it's this string decoder you need to decode the string start from I+1 and at the length. So right now the ending index, say ending index, my length is 2, starting index is 0, ending index should be 0, 1, 2. But just add as a length, we should be able to find the last index. Okay. Now let's write a decoder. Private string decoder. Let's take a string. Return the decoded string. String buffer, let's say string buffer sb equal new string buffer, and finally we need to return sb to string. For this string buffer, what we can do is, we know this one have well formatted brackets. Then we can remove the first brackets and the last brackets. Then we can do, what we can do is, we can call solve. Solve should return me something. After that, let's return the result. Let's don't do this. Let's create the result string buffer at the beginning. Oh, let's start to get agony. Okay, the result. Let's return result to string. To string. This is minus clouded. It's definitely have a better way of solve this, but okay. Now we returned. So here, the result to string. We can return the result to string, and in the decoder we can call them. In the decoder, what we can do is we can strip away the okay. We can do solve. In the decoder we can do solve. Show the string str substring from 1 to str length. Yeah, not include the last one, and that will give us a string we want. So instead of call decoder, let's just do this. Okay. Let's return this. And we should have something. String length 64. ACC ABC to CC. Yes, we got this solution. It's definitely not optimized, but whatever. Let's think about the time complexity. We examined each character. When we meet a number, we actually looking forward in order to get the length of the matching brackets. This searching could cost ON, because this searching could cost ON. After that, we recursively looking into that substring in order to solve the problem. So the total cost is hard to estimate, but it's more than ON. How about the lower bound is ON? How about space complexity? The space complexity is here we see like a recursive call. As the worst scenario, we could have this stack depths equal proportional to n, so the space complexity should be ON in the worst scenarios. So this algorithm is a little bit more than ON, time complexity and the space complexity ON. Of course, it's kind of quite messy. Let's do this and see what this returns. Okay. How about this one? Yeah. So this is a correct answer, even though it might not be optimized. Okay.